Welcome friends to our channel Chemistry is Awesome. The first law of thermodynamics for various processes. See here, first law of thermodynamics for various processes. First law of thermodynamics, its mathematical equation. Just we saw, I'll write here, change in internal energy delta U is equal to Q plus W. So this is the mathematical expression for first law of thermodynamics. What is Q? So that is the heat supplied to the system, and what is W? Work is done on the system but by the surrounding. In both the cases, internal energy of the system increases. So how this mathematical equation means first law of thermodynamics, it can be applicable for various processes, and how this first law of thermodynamics can be written for various processes. We saw the processes. There are four types of processes. One is isothermal process, another is adiabatic process, third is isochoric process, and fourth is isobaric process. You see here, first I will write here isothermal process. Second, adiabatic process. Third, isochoric process. And fourth, isobaric process. How this mathematical equation of first law we can show regarding all these processes. You see here, in isothermal process, you saw the definition of isothermal process. It is the process in which temperature of the system remain constant. So that is isothermal process. Means during this process, if heat is evolved during a chemical reaction, that evolved heat is given by system to the surrounding and its temperature remain constant, and required heat is taken by the system from the surrounding to maintain its temperature constant. Means in isothermal process, temperature T constant. As temperature constant, then its internal energy U also remain constant. And since internal energy is constant, then change in internal energy delta U is equal to 0. In isothermal process, delta U is equal to 0. Then by putting the value of delta U in above first law of thermodynamics equation, delta U is equal to Q plus W. Means here delta U is equal to 0. If you put delta U is equal to 0, then Q 0 is equal to Q plus W, or we can say that Q is equal to minus W, or W is equal to minus Q. You see these equations. Suppose it is 1, suppose it is 2. Equation 1 and equation 2, what it indicates? Means isothermal process, if temperature of the system remain constant, then if you supply Q amount of heat to the system, then total heat is utilized to do the work by the system of the surrounding. Total supplied heat is utilized by the system to do the work of expansion, because its temperature remain constant. Means its internal energy of the particular system remain constant. There is no any change taking place in internal energy of the system. Therefore, supplied heat is totally utilized to do work of expansion or to do work by the system on the surrounding. So that is the meaning of this equation 1. Means at isothermal process, supplied heat is totally utilized to do work of expansion. And what this second equation indicates, if work is done on the system by the surrounding, means positive W. If work is done on the system by the surrounding, then it results in a release of heat. You see here, if work is done on the system by the surrounding, then what happens? Internal energy of the system increases. But in isothermal process, this change in internal energy is 0. There is no increase in internal energy of the system. Therefore, the work, when it is done on the system by the surrounding, then what is the internal energy increases, so that gets released. So in this way, we can explain and the first law of thermodynamics for isothermal process. We'll see what is meaning of adiabatic process. What is regarding the adiabatic process? In adiabatic process, it is the process in which heat is neither allowed to enter nor leave the system to the surrounding. Means here, in this adiabatic process, Q is equal to 0. Q is equal to 0. It is neither taken in by the system from the surrounding nor given out by the system to the surrounding. Means here Q is equal to 0. By putting this value of Q is equal to 0 in this first law of thermodynamics equation, what we will obtain? If you put Q is equal to 0, then delta U is equal to W, or minus delta U is equal to minus W. Meaning of both, it is same. In adiabatic process, Q is 0. By putting the value of Q 0 in the first law of thermodynamics, delta U is equal to W. Delta U is equal to W. No doubt, it is a plus 1. And if you have taken minus sign to both, minus delta U is equal to minus W. What it indicates? Plus W means if work is done on the system by the surrounding. These two equations implies that when work is done on the system, then its internal energy increases. Its internal energy of the system increases because work is done on the system by the surrounding, and that work is done on the system, it adds the internal energy of the system. So that is delta U is positive. So there work is done on the system, then internal energy of the system increases. And what this negative work indicates? Work of expansion. Work is done by the system on the surrounding. That work of expansion indicates that, so that is the decrease in internal energy of the that particular system. In adiabatic process, when work of expansion takes place, so that is very important point in the view of a NEET. In adiabatic process, when work of compression takes place, then its internal energy increases. And in adiabatic process, work of expansion takes place, then its internal energy decreases. That is the meaning. Because for expansion process, it is not taken in from the surrounding, but that heat or internal energy, so that takes in the system itself, and therefore its internal energy decreases in adiabatic expansion process. Then we will go towards isochoric process. What about isochoric process? You know that it is the process in which volume of the system remain constant. When volume of the system remain constant, then change in volume delta V is equal to 0 in isochoric process. You see, in isochoric process. In isochoric process, initial volume and final volume remain constant. There is no change in volume takes place in isochoric process. Therefore, change in volume delta V is equal to 0. How this isochoric process is to be carried out? Generally, this isochoric process carried out in a closed container, in a sealed container. any process is to be taken place in sealed container, means there is no increase in and there is no decrease in volume of the container takes place, means volume remain constant, initial volume, final volume remain constant. Therefore change in volume in isochoric process delta V is equal to 0. You see here in first law of thermodynamics, delta U is equal to Q plus W. We saw the expression for work done in PV type of work or in simple work. What is the work done W? W is equal to minus P delta V, P external into delta V. So this P external means the pressure which is applied on it, so that is the external pressure, and delta V, so that is the change in volume. Here if you put this in this equation, we will get delta U is equal to Q minus P delta V. No doubt this P is external pressure. In isochoric process, we know that change in volume is 0, means what the system, so that is taken place in a sealed container, means in sealed container there is no increase or decrease in volume is there, so therefore change in volume delta V is 0. By putting this value 0, this whole term gets 0, means work done is 0. Work done is 0 in case of isochoric process, and therefore delta U is equal to Q V. V means at constant volume. You see here, this happens, or this is the first law of thermodynamics for isochoric process. Means here what happens, change in internal energy, whatever may be taking place, so that is at constant volume. Heat supplied at constant volume, then the supplied heat is totally utilized to increase the internal energy of a system. See here, QV, what it indicates, the heat supplied at constant volume, it is totally utilized to increase the internal energy of the system, so that is delta U. We know that U is the internal energy, so that is the state function, and it is the extensive property we saw already. So this is the state function. This delta U is state function, therefore QV is also a state function. But we know that what is Q? Q and W means heat and work. These are the path functions. We keep in mind. But QV is a state function, because QV is nothing but the delta U, and delta U means U, so that is the energy, and delta U change in internal energy. So these are the state functions. Therefore QV is also a state function. Then we will go towards last, isobaric process. I will write here, that is isobaric process. Just we saw the first law of thermodynamics, delta U is equal to Q plus W. Isobaric process means it is the process in which pressure of the system remain constant. Pressure of the system remain constant, and then change in pressure delta P is equal to 0. Here in isobaric process, pressure remain constant, means here work of expansion or work of contraction is always taking place against a constant external pressure applied on the piston, and this is generally, so that is the atmospheric pressure. Means at constant external pressure is applied on the piston from external side, then the work of contraction and work of expansion may take place. If work of contraction takes place, piston will be pulled in downward direction, and when work of expansion takes place, then piston will be moved in upward direction, means volume gets changed. Means here in this isobaric process, delta P is equal to 0, but delta V is not equal to 0. In this isobaric process, delta P is equal to 0, but delta V is not equal to 0. In isochoric process, delta V is 0. In isobaric process, delta V is not equal to 0, but delta P is equal to 0. By putting work, delta U is equal to Q minus P delta V, P external pressure. And this is the isobaric process, means heat supplied to the system is at constant pressure, so it is divided by QP. So it is QP. As here it was QV, but here it is a QP. So therefore QP is equal to, if you transfer this to the left hand side, you will get delta U plus P external into delta V. So that is the equation for first law of thermodynamics in isobaric process. But this isobaric process, QP, is also denoted by a symbol, so that is delta H. QP is also denoted by symbol delta H. Then the same equation can be written as delta H is equal to delta U plus P delta V. So in this way we can explain the first law of thermodynamics for various processes. I hope that you should understood all these points. So in short I will repeat all these 4 types of processes and how mathematical equation can be given here. In isothermal process we know that the temperature of the system remain constant, and then as temperature remain constant, then its internal energy also remain constant, means change in internal energy delta U is equal to 0. So by putting this value delta U is equal to 0 here, you will get Q is equal to minus W, and Q is delta U is equal to 0, you will get Q is equal to minus W and W is equal to minus Q. Here Q is equal to minus W or W is equal to minus Q. Then in adiabatic process what happens? In adiabatic process, Q is equal to 0 because it is neither allowed to enter nor leave the system to the surrounding, means Q is equal to 0, and value of Q is equal to 0 here, then delta U is equal to W, delta U is equal to W, or minus delta U is equal to minus W. What about in isochoric process? In isochoric process we know that it is a process in which volume of the system remain constant and change in volume delta V is equal to 0. In isochoric process, here delta U is equal to Q plus W and delta U is equal to Q. So that is the formula for work. So that is we kept here instead of W, minus P delta V is kept here, and delta U is equal to Q minus P ext into delta V. But at constant volume, this change in volume delta V is 0 and total work done is 0 at constant volume, because in constant volume any process is taking place, then it is taken in a sealed container, means there is no expansion or there is no contraction of gas takes place, means there is no question of work done there. So there this value of work done is 0, and therefore delta U is equal to Q, and that Q is at constant volume, means heat supplied to the system it is at constant volume, then supplied heat is totally utilized to increase the internal energy of the system, and their work done is 0. So therefore delta U is equal to QV, you can write here. And in isobaric process, it is the process in which pressure of the system remain constant, means change in pressure delta P is equal to 0, means in isobaric process this process is carried out at constant pressure, at constant external pressure, means change in volume takes place, means change in volume delta V is not equal to 0 here, keep in mind. So therefore delta is equal to QP minus P external ext delta V, means value of work is kept in this equation. Then if you transfer this P delta V to the left hand side, then you will get delta U plus P delta V, and QP is equal to delta U plus P delta V. So that is the equation for first law of thermodynamics in case of isobaric process. And this QP means heat supplied at constant pressure. It is given by a symbol delta H. So therefore, we put this delta H in this equation. We will get delta H is equal to delta U plus P delta V. So in today's period, we saw the 3 points. Which are these 3 points? Internal energy, how internal energy change taking place by different ways. Then first law of thermodynamics and formulation of first law of thermodynamics means mathematical expression for first law of thermodynamics. We saw 3 different statements of the first law of thermodynamics. Meaning of all these 3 statements is same. That is the total energy of the universe always remain constant. This first law of thermodynamics is also called as law of conservation of energy. Energy can neither created nor destroyed, but it can be converted from one form to another form. And its mathematical equation is delta U is equal to Q plus W. And in third point we saw that how this mathematical equation it is obtained for various processes, means isothermal process, adiabatic process, isochoric process and isobaric process. So this is the mathematical part. You understand clearly, don't be mug up. You understand all these things clearly and then you can face any question asked in NEET exam, JEE exam, IIT exam. We will see the problems and various types of questions at the end of topics. Okay, you have to solve one NEET question at your home. Its answer I will tell you in next video. Okay, thanks.